Welcome to the Specimen Not Found podcast. This podcast explores the life and careers of clinical laboratory science professionals and discusses issues that can help inform other members of the healthcare team and the public about what makes clinical laboratory science such a critical profession within healthcare. We are your hosts.
I'm Dana Bostic.
Drew Jones.
And Letycia Nunez-Argote. How have you guys been?
It's good.
Yeah,
What have you been
no
up to?
complaints.
Lots of work.
Yeah.
Definitely, but
Did you
in
know-
a good way.
Do you know Dana's a superhero?
I know she is, but do tell us why.
We don't have time. That's going to be a
okay.
different episode.
Oh my
Okay.
goodness.
So, in our previous episode, we followed the story of Casey Perez, aka CP, a 63-year-old male whose samples had been analyzed on the chemistry, hematology, and coagulation, aka COAG. In today's Parte 2, we will continue to talk about the various areas of the clinical lab to tell CP's story and the story of his sample.
So you may recall from our previous podcast when we last saw our friend CP, our chemistry medical laboratory scientists reported a high glucose and abnormal protein level. Our hematology lab identified abnormally high white blood cell counts, low hemoglobin level, low platelet level, and our coagulation report indicated slow clotting times, all of which put CP at an increased risk for bleeding and indicates a probable diagnosis of diabetes. Additional testing showed an increased C-reactive protein, or CRP, and SED rate, both values which are general biological indicators that the body has inflammation. The clinician receives this data and, based on their body of knowledge and a few other clinical or diagnostic tests, decides further testing is required to really get to the bottom of this mystery. The next day, CP's physician decides urinalysis studies would be helpful, so she orders a UA test or urinalysis test with microscopy along with a reflex test for urine culture.
So let's first explore urine analysis. We could spend all sorts of episodes discussing the importance and everything that goes into UA, but let's do a quick overview for y'all. Urine analysis takes both a microscopic and macroscopic look at freshly collected urine. Both the micro and macroscopic analysis of the urine can identify many different clue substances that indicate numerous different clinical ailments. These include, but aren't necessarily limited to, the color of the urine, the clarity, whether there's ketones or bilirubin present, the specific gravity, if it's changed from normal, a change in pH, and also we can see a whole range of different types of cells, red blood cells, white blood cells, and then some cells from our kidney and renal areas. From this data, we can also obtain hints for what's causing it, whether it be bacterial, kidney dysfunction, renal dysfunction, or protein abnormalities. We can fine-tune our UA results to tell us exactly what part of the urinary tract the infection is occurring in, or what part of the urinary system is malfunctioning. So let's now talk about the reflex test for urine culture.
Now, wait a second, Drew. I would like to get a little bit more information about what a reflex test is.
That's a great question. So oftentimes ordering sets are built so if there's a certain number of parameters identified or flagged, we can automatically trigger further testing. So these reflex tests eliminate the need for a physician to interpret the data in real time and immediately order pertinent follow-up tests. So one of the most prominent reflex tests we see in the clinical lab is urine reflex testing. For example, abnormal findings in nitrate, leukocyte esterase, blood, or even the presence of bacteria all clearly point to the presence of a UTI. Each one of those being positive can trigger a reflex for urine culture.
With that being said, let's take a look at our patient Casey Perez's, or CP's, urinalysis results. So if you are watching this on YouTube, then you are able to see the urinalysis results. But for those of you only listening, let me go over a couple of key high-level, sections of this report. So upon physical examination of the urine, the color was great. It was yellow, which is typical, normal color that we want to see for our urine. But the clarity or turbidity of the urine was actually cloudy. And upon chemical examination, we noted that there was a trace of blood present in the urine, as well as a 4+ or a high level or high presence of protein in the urine. We also noted a positive identification or positive presence of white blood cells. Nitrate was positive, which is indicative of the presence of bacteria. And then Interesting enough, we had a glucose reading of negative for the urine.
Yeah, why is that? I mean, when we're looking at chemistry results for CP, I remember that his glucose was really high, and usually when a person has really high glucose, then you would see it in the urine, right?
Yes and no. Yes, you could have a high level of glucose present in the blood, and usually that does spill over to the bladder or the urinary tract. However, if there's both a presence of bacteria and glucose, bacteria loves to consume or start to feed on glucose as its food source.
Nom, 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 nom.
Exactly. So after that Pac-Man action on the glucose, it could then end up being negative in the urine.
Oh, wow. And that would be in the chemistry, right?
In the chemical analysis. And so with that being said, along with that chemical analysis, this is why we do the microscopic exam, just to confirm that train of thought that we are on the right path and identifying that. So when we did our microscopic exam, we did actually see the bacteria present in the urine, which then supports the argument that, the glucose would be negative on the chemical exam because of the high presence or high amount of bacteria present in the urine. We also noted white blood cells being in the urine, as well as hyaline and white blood cell cast being present. So what we're seeing here is very indicative of a typical urinary tract infection, also known as a UTI, which is most likely in the upper urinary tract, as indicated by the presence of what we refer to as transitional epithelial cells, which is most likely caused by an enteric gram-negative rod, like E. coli, for instance. I know a lot of people are very familiar with E. coli.
It's in your lettuce.
Right, or in your burgers. That's always the fear, right?
Mm.
And so, as we discussed before, these results would undoubtedly result in a reflex urine culture being ordered.
So that day in the microbiology lab, they go and they acquire a urine sample from chemistry, and they set up the urine culture. Now, in microbiology, we have to grow the bacteria or the yeast, so they'll sit overnight in an incubator. We set up a standard set of plates for each type of culture. With urine cultures, we typically do a non-selective media like a blood culture, and this allows and acts as a catch-all, and it allows everything or anything to grow. The other plate we'll add is either going to be a McConkey agar or an eosin methylene blue or EMB agar. These are selective media that only allow for the growth of gram-negative rods, like our E. coli. And they do that by containing certain nutrients or components that are going to hold back everything else, whether it be fungal or yeast or a gram-positive like staph or strep. So after 24 hours in the cooker, our microbiology MLS reads out CP's urine culture. Luckily enough, the growth patterns point to E. coli. E. coli is one of the few bugs that it shows very distinct growth patterns that allow us to identify it without complex biochemical or protein analysis like our MALDI-TOF. Now, the MALDI-TOF, just real quick, is the newest microbiological identification technology out there. In short, what it does is it shoots lasers at bacteria, and based on how those bacteria explode after being shot by lasers, we can identify the bug. It's a little more complex than that, but we'll leave it there. So once we've got our identification, we need to figure out how to treat this bug. So our micro laboratory scientist is going to set up an antimicrobial susceptibility test. And this determines what the best antibiotic therapy for our particular strain of E. coli is going to be. Most times nowadays we use automated instrumentation to run our AST testing, but as you can see here, we've shown you what it looks like in the old school, or what we teach in school, and you can see what a susceptible antibiotic would look like versus resistant. And what that means is the susceptible antibiotic would work in our patient to treat the UTI.
Okay, so now that we have identified what antibiotic will be most effective in treating CP's E. coli, the medical laboratory scientist can report those findings to the physician and they can start his treatment for his infection. So for this particular strain of E. coli, it is not an overly resistant strain, which is good news for CP, and it can be treated with basic cephalosporins. Oftentimes, enteric gram-negative rods can develop high levels of antimicrobial resistance to carbapenem, penicillin, and other cephalosporins that can make the organisms much more difficult to treat. But we will discuss this much more in a later episode. After a follow-up visit with his primary care physician, CP has been put on a new therapy regimen for his diabetes, and his antibiotics have eliminated his urinary tract infection.
Yay! So I actually wanted to say about the susceptibility testing. I was trained with the disc stuff, so the MALDI was super new for me, and I really appreciate you explaining that to us today, Drew.
You're welcome.
Yeah, that's really neat. Just the fact that, the use of lasers.
Yes.
that
Are
just
there
makes it sound
chickens in
exciting.
there?
I wish there were mutated chickens in there.
Aw.
I'm not allowed to open it.
Oh, okay.
Voids the warranty. But I assume there's probably chickens in there.
Okay. That's what I thought. And so, of course, this was a mock patient case, but every day, thousands of patients are treated using the clinical data generated in the laboratory. As MLSs, we may not meet the patients face to face, but sometimes we see somebody's name come on the screen more than once throughout their treatment process. And that connection between us and the patient can really be made in that way. In my experience working in the clinical lab, I've had cases where I would work in the microbiology, just briefly setting up or getting blood cultures read and set up for the subsequent testing that the professional microbiologists would be doing. But just looking at that name that day, then a couple of days later, they would come up in the hematology area doing a complete blood count to see how the antibiotic treatment was helping reduce the infection. Or in chemistry, looking at their metabolic panel to see if they were getting better. And so following the samples throughout the lab is really helpful to kind of have that connection with our patients.
All right, that's true. And another way that we can connect with our patients, which is a surprising way or an interesting way that we would connect, really spills over into our personal lives. We do our work in the lab, we go home, we watch the news, and then you're hearing names and seeing stories that are very familiar with the case at work, whether it's someone that was in a motor vehicle accident. More than likely, if they went to a local medical center in that same city, you were the tech that worked on their samples. You're part of that healthcare team saving lives. And so I believe as a medical laboratory scientist that resonates with you more, and that, there's a person, there's a family, there's a community behind every sample that we work on.
Definitely. The other thing, as a microbiologist, we work a lot with cystic fibrosis patients. We start seeing these kids' cultures at a very young age, and with the advances in cystic fibrosis treatment, we see patients for years.
Well, and it shows how we care. We really, really do care for our patients.
Absolutely.
Exactly.
Absolutely.
So if you actually want to see a video that kind of shows the experience of a patient from diagnosis to treatment all the way to their cure, both from their family and from the perspective of the healthcare professional, we strongly recommend you check out a video, A Life Saved. It's a short but powerful story that shows how important the laboratory is to every patient. And we'll provide the link in the description for you.
And that is it for our podcast today. In our next episode, we will have our first guest to the podcast.
Ooh.
And so you will hear voices besides our own. And that would be a great opportunity to hear the insight and perspective of other people in our profession, in our field. So we will have contributions from some of our former students, as well as colleagues who are currently working in the clinical laboratory. If you would like to contribute your story, send us a message, and we will be happy to share your testimonial. You may message us or record a short 30-second audio completing sentence that will start with, "I proudly serve as a clinical or medical laboratory scientist or technologist because," and we kindly request for you to complete that sentence.
Yeah, and we hope that you will connect with us. You can find us on Facebook at KUMC CLS Program or visit us at cls.kumc.edu. And don't forget to share this podcast with all your friends. This podcast was written, recorded, and produced by us at the University of Kansas Medical Center with the technological assistance of Mr. Terry Arisman. Thank you for all your help.
Thank you, Terry.
Thanks, Terry.
And for now, this has been The Specimen Not Found.
I'm Drew Jones.
I am Dana Bostic.
And I'm Letycia Nunez-Argote.
Bye.
Bye.
Bye.